welcome to our YouTube channel. So today we are going to start a new topic, that is factors and multiples. So if we talk about the factors are those numbers which divide a particular number completely, and multiples are those numbers in if we multiply any number by some number, so the product is called our multiple. So let's see what we are having regarding these two topics. So if we see, okay, if we look at the topics just like multiples, properties of multiples, factors and divisors, properties of factors, even odd numbers, prime composite numbers, prime factorization, and test of difficulty. Okay, these are the topics which we are going to cover in this. So first we are going to talk about the multiples. So let's see what we are having. When two or more numbers are multiplied, we get the product, and the product is called the multiple of each of the numbers multiplied. Example, the product of 5 and 7 is 35. Thus 35 is multiple of 5. So also it is a multiple of 7. I told you that if we multiply any two numbers and the product is the multiple of that numbers. So here we are having 9 in 1s are 9, 9 2s are 18, 9 3s are 27. So these are the multiples of 9 and 4, 5, 6, 7, whatever you think. Clear? So now come to our next part. Okay, here we are having properties of multiples, just like A part. Every number is a multiple of 1 and itself, because if you multiply any number by 1, the number is itself. In these examples, we find each number is a product of 1 and itself, and each number is a multiple of 1 and itself. Now come to a second part. Every multiple of a number is exactly divisible by that number. So let's see, here we are having 7 multiplied by 8 is 56. So 56 divided by 7 is 8, 56 divided by 8 is 7. So we are having that number is the multiple is exactly divisible by the other two numbers. So now we are going to next part, that is C part. That is 0 is the multiple of every number, because if we multiply any number by 0, then we are having 0. So next is D part. Every non-zero multiple of a number is either greater than or equals to that number. That is 5 multiplied by 1 is 5, 15 multiplied by 1 is 15. 8 4s are 32 and 7 4s are 28. Just like this. Okay, here we are having some examples. Okay, now we are having our exercise 4A. There is a question number 1. Write the first 5 multiples of the following. So let's pick C part. So first 5 multiples of 11. That is 11 1s are 11. 11 2s are 22. 11 3s are 33. 11 4s are 44. 11 5s are 55. Clear? So these are the multiples of 11. If we talk about find the 10th multiple of the following number, so we are simply going to multiply by 10, and this is the 10th multiple of that particular number. Okay, let's pick question number 4. So here we are having find the multiples of 6 lying between 50 to 100. So if we look at after 50, so 6 9s are 54, then 6 10s are 60, then 66, then 72, then 78. Yes, 78. Then we are having 84, and then we are having 90 and 96. How many multiples of 6 are there? Just count them. 1, 2, 3, 4, 5, 6, 7, 8. So our final answer is 8. Clear? So next we are having question number 6. Write first 10 multiples of 3 and find out the multiples of 5, 6 and 15 amongst them. Okay. Let's pick C part, sixth question. So here we are going to write the first 10 multiples of 3. So we are having 3, 6, 9, then 10, 11, 12, 15, 18, 21, 24, 27, and 30. So now we are going to find out the multiples of 5. So we are having 15, then 30. After that, we are having multiples of 6, just like 6, 12, 18, and 30. Now we are going to find out the multiple of 15, that is 15 itself and 30. So these are the multiples among them. Now move to our next part. So here we are having factors and divisors. So let's see. When two or more multiples are multiplied, we get the product, and each number is called the factors of the product. Just like we multiply two numbers and we have a product for this 6, the factors of 42 is 6 and 7. So now if we look here, we are in 48, that is 48 into 1, 48 for 12 into 4, 42 into 24, 6 into 8, and 3 into 16. So these all are the factors of 48. Clear? Now let's see what we are having next. That is the properties of factors. Just like A part, 1 is a factor of every whole number. Okay. Just like if we multiply any number by 1, so this is the factor of any number. Every whole number is a factor of itself because the same number is divided by itself. So we can say that after this we are in C part, every whole number except 1 has at least two factors, just like 1 and the number itself, because 1 is a unique number and those numbers who have only two factors are called the prime numbers. So let's see the note here. 1 and the number itself are said to be the improper factors of a number, whereas the factors other than 1 and the number itself are called the proper factors. Clear? So when you are having the factors other than 1, then we can say that these are proper factors. Now come to our D part. Every number is a factor of 0 because if you multiply number by 0, then you have answer 0. Next is E part. Each factor of a number except 0 is either less than or equals to the number. So here we are having, so the limit of factor is, that is except 0 is either less than or equals to a number. Listen. Here we are having 12, the factors 12 are 2, 2, 3. So these are the numbers which are less than or equals to. Okay, here we are having exercise 4B, that is question number 1. So that is find the factors of the following. Okay. So let's pick F part. So we are having factors, those numbers which divide the number completely. So I'm going to write here the factors. Just like 1, 2, 4, then 5, 8, then 10, then 20, and I think 16 5 80 is also there, that is 16, 20, then 40, and then 80. So these are the factors of the number 80. Clear? Next we are having 9 is a factor of this. If we have to find out the 9 is a factor of this, so we are going to divide these numbers. So if this number is completely divided by 9, so we can say that it is a factor. Clear? So we can say that, let's divide it first. Okay, 9, 2, 0, 4, 3. 9 1s are 9, 9 2s are 18, then again 24, 9 3s are 29, 2s are 18, that is 63. So 7 9s are 63. Answer. So this is our factor, that is 227. So we can say that 9 is a factor of this number. Clear? Okay, next is write the common factors. So you can also do this question by in this way also. Okay, now come to question number 5. 4 and 12 are the factors of 48. Can there be any other factor of 48? If yes, right then. Okay, here we are in 4 and 12 are the factors of 48. Okay. Can there be any other factor? Okay. If yes, right then. So 4 and 12 are the factors, so we can say that the remaining factors. Just like 1, 2, 3, 6, 8, 18 also a factor of this. Then 24 is also a factor of 48. And the 48 also a factor of itself. So these are the remaining factors. So next, okay, in question number 8, is the first number a factor of the second number? Okay, so you have to check that 81 is divisible by 9. So when it says, so then it is a factor. So here we are in question number 10. Fill in the blanks. So 6 and 18 are the factor of this. You can say that yes. Okay, now move to our next part. Now we are having even and odd numbers. Even numbers are those numbers which are exactly divisible by 2. Okay, for example, just like 2, 4, 6, 8, 10 are even numbers, or if we have any other number in which we are having the 2-digit number, 3-digit number, so we have to check that the ones place are having the multiples of two numbers, just like 2, 4, 6, 8, 0. So we can say that if at ones place we are having these numbers, they are also even numbers. So let's see the definition first. Even numbers, a number which is multiple of 2 is called the even number. And in other words, even number, those numbers which are divisible by 2 are also called even numbers. Examples are these. Let's see, here we are having 2, 4, 6, 8 and 0. So you have to look at the ones place. If they are even numbers, then whole number is a even number. Okay, then we are having odd number. The odd numbers, a number which is not a multiple of 2 is said to be the odd number. See, just like 1, 3, 5, 7, just like these. Now we are having our exercise 4C. Let's pick one question from here. Just like second part. So here we are having write all the even numbers between 50 and 70. So just like we are talking about even numbers, so we are having 52, 54, 56, 58, 60, then again 62, 64, 66, 68. So these are the numbers between 50 to 70. Okay. Next come to, okay, now let's start our sixth question. Encircle the number which are divisible by 2. That means we have to check which one is even number. So this is a even number, this is also an even number. So those are even numbers are exactly divisible by 2. Okay, so here we are having one more question, that is question number 8. What is the least number that should be subtracted from an even number to get an odd number? That is 1 as an answer. If we subtract 1 from any even number, we will have always a odd number. Next we are having, that is the prime and composite number. Prime numbers are those numbers which have only two factors, that is 1 and the number itself. And composite numbers are those numbers which have more than two factors. Many clips. Okay, so let's see. The counting numbers 1, 2, 3 may have one or two or more factor examples. So 1 has only one factor, 2 has two factors, 3 has two factors, 7 has two factors. So those numbers which are having two factors are called prime numbers, and the number which are having more than two factors, just like 18 has 6 factors, so these are composite numbers. So here we are having the number which has only two factors, 1, and the number itself is called a prime number or primes. Example, the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So to find out the prime numbers, we can adopt Steve of Eratosthenes' method, which was discovered by Greek mathematician Eratosthenes. So here we are having table, the cross out 1 and cross out all the numbers which are divisible by 2 except 2. So I think we are having a table. Okay. So first we are going to cross the multiples of 2, then multiples of 3, then multiple of 5, multiple of 7, then multiple of all prime numbers. Clear? So this is how this works. So except 1, those are remaining numbers are the prime numbers. So let's see what we are having. Okay, next is twin prime numbers. The prime number which differ by 2 are called twin prime numbers or twin primes, just like 5, 7, 11, 13. These are the prime numbers and also have a difference of 2. Next is composite number. A number except 1 which is not a prime is called a composite number, and composite number has more than two factors. Just like 6 has 4 factors, 8 has 4 factors, just like this. Next is perfect number. Perfect number are those numbers if we add the factors of that number is equals to twice of that particular number. See, let's see, we are having 6. The factors 6 are 1, 2, 3, 6. If we add these factors, these are twice of the number. Clear? So these are the perfect numbers. So come to our exercise 4D. So here we are having question number. Here we are having which of the following numbers are prime. So let's see. Just like 37 is a prime number, and we are having 59 is also prime number. So next we are having 67 is a prime number. 71 is also a prime number. So this is how you are going to find out the prime numbers. Next is question number 2. Which of the following are composite numbers? Just like 9, 21, 31. Those numbers which are having more than two factors are called composite numbers. Next is question number 3. Write the prime numbers between. Okay. Let's pick A part. So after 41, 40, that is 41, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. So these are the prime numbers which are 40, which lies between 40 and 60. Clear? So come to the next part. That is question number 4. Determine a pair of prime number less than 100 which differ by. Okay, so we can say that directly here, just like if we talk about these, that is 3 and 5 are the two prime numbers which are differ by 2. So come to our next part, that is question number 5. Name the smallest prime number greater than 20. So after 20, 21, 22, 23. Okay, that is the smallest prime number after 20. Clear? So see, in the same way, if we look for the B part, next we are having 40 mark. So that okay, so next parts are for you. Next is question number 6. Name the largest prime number less than 90. So we can say that 89. Okay. Next is question number 8. Write an even prime number. So even prime numbers we are having just like 2 only. Now come to our next part. So here we are having question number 9. Express the following as a sum of two prime numbers. How many pairs of prime numbers are possible? So you can do that just like, let's see, one pair of 16. So we can say that 16 and the two prime numbers, okay. The first we can see just like 5 and 11. Okay, 6, 7. If we took 7, then we are having 9. No, it's not possible. Then 11 plus 5. 2 and 14. No. Prime numbers 3 and 13. Yes, 3 and 13 is also possible. So we can say that 3 and 13, 4, 5 and 11, 6, 7. Not possible. 8, 9, 10. Yes, these are the two pairs of prime numbers. If you sum them, you will find the 16. Okay. Next is find prime factors of the following. So if we talk about the prime factor, let's pick 24. So now we are going to divide it by the prime number just like 2, then again 2, then 2, and this is 3. So the prime factors are these numbers. 2 multiplied by 2 multiplied by 2 multiplied by 3. Okay, rest part is for you. Now come to our next topic. Let's see what we are having. Prime factorization. If we talk about prime factorization, we are having some numbers. So we are going to divide it by only prime numbers and see how many numbers are there till it is completely divisible. Okay, now we are having our exercise 4E. Now come to question number 1. Prime factorization of some numbers given below, find the number. So we are going to find out this part H. When we are having prime factors, so we are going to find out the number. So we are going to multiply these numbers just like 2 5s are 10 5s are. So 2 5s are 10 into 5 into 7 into 7. Then we are going to multiply 10 into 5, that is 50, and 7 7s are 49. So we are going to multiply these numbers. 9 5s are 45, then 4 5 are 24, and this is 0. So the required number is 2450. Now we are having question number 2. Find the prime factorization of the following numbers. So let's pick G part. So 1225. Okay, so this is 2. 6 2s are 12, 2 1s are 2. Sorry. we are going to divide it by 5. So 5 2s are 10, 5 4s are 20, 5 5s are 25, then again divide by 5, 8 5s are 40, and 9 5s are 45. Sorry. क्या कर रहा हूँ मैं? Okay. So we are going to divide it by 5, that is 5 4s are 20, and 5 9s are 45, then again divided by 7, then 7s are 14, and again 7 1. So the prime factors of 1225 is 5 multiplied by 5 multiplied by 7 multiplied by 7. Clear? Okay. Now we are having question number 3. Determine the prime factorization of the following given numbers and to find the common factors in each case. Okay. Let's pick these two numbers. We have to find out the common factors. So here we are having 32 and 40. So if we find out the factors of 32 are so we are having factors 2 multiplied by 2 multiplied by 2 multiplied by 2 5 times. Then we are going to find out the factors of 40. Okay, so these are 2 we have to multiply 2 3 times and then 5. So if we talk about common factors, we are having 2 multiplied by 2 multiplied by 2, that is 8. Clear? Next is question number 4. Find the factors of 270 whose sum is 33. Next is question number 5. Find the common factor of the following pairs of numbers. So these are the same which we are having. So let's pick question number 4, A part. You can do the question number 5 as we have done question number 4. So now pick the factors of 270. Just select 2, 1, 3, 5. 5 2s are 3 and 3 9, 3 3, 3 1. So we have to find out the factor whose sum is 33. So we can say that 5 2s are 10, 3 is a 9, 3 is 27, and plus 10 not possible. 3 2s are 6, 6 2s are 12, and 5 3s are 15. 3 2 is 6, 6 to 12, 12, 3s are 36, 9 2s are 18, 18 plus 15. Okay. So by making the combination of the factors, we are having the answer. That is, if we look, 3 3 is a 9 to the 18, and we are having 5 3 is a 15. If we add these two factors of 270, we are having 33 as the answer. Clear? Okay. Now come to our next topic, what we are having, let's see. So these are the factors you can do by your own. Now come to 8th part, that is find the prime factorization of the pairs of numbers. In each case, determine whether the smaller numbers divides the larger number. So in this case, you can see this is 6, 0, 0, and 6 is divided 40. No, it is not possible. You can divide and check whether they can divide it or not. So next is the divisibility of numbers. So this is test of divisibility. We are having the first A part divisible by 2. So if we find out at the ones place, we are having 2, 4, 6, 8, 0, or we can say that the even numbers and the particular numbers divisible by 2. Now come to divisibility by 3. If we have to check the divisibility by 3, so we have to just add the digits. If the sum is divisible by 3, then the whole number is also divisible by 3. Now come to our next topic. To check the divisibility by 4, we have to check last two digits of a number. If these two digits of a number are divisible by 4, then the whole number is divisible by 4. For checking divisibility by 5, we have to check that at one place we are having 0 and 1, just like we are having 75, 5, 0. So these are the numbers which are divisible by. Next is divisibility by 6. If we have to check the divisibility by 6, we have to complete the check of divisibility by 2 as well as divisibility by 3. So for divisibility by 2, we are going to check the divisibility test of 2, and for checking the divisibility by 3, we have to just add the digits of the number, and if the sum is divisible by 3, then it is possible. If the number is divisible by 2 as well as 3, then it is automatically divisible by 6. Next is divisible by 9. So we are having the number, if we add the digits and just like the divisibility test of 3, and the sum is divisible by 9 here, then the whole number is divisible by 9. So come to our next part, then divisibility by 10. In divisibility by 10, we have to find out that 0 at the ones place. If it is there, then it is divisible by 10. So we are having exercise 4F. Question number 1, which of the following numbers are divisible by 2? Okay. So it is easy. Here we are having 2. So it is divisible by 2. Here we are having 3. It is not divisible by 3. Clear? Okay. Next we are having question number 4. Which of the following numbers are divisible by 4? We have to see last two digits just like this. This is also divisible by 4. Next is question number 6. Which of the following numbers is divisible by 3? So here we don't have even number, so we can check them. If the sum of digits of this number is divisible by 3, then we can say that it is divisible by 3. So first we are going to find out the sum of digits, just like 5 plus 4 plus 3 plus 9. This is 9 to the 18 plus 3 is 21, and this sum is divisible by 3, then this whole number is also divisible by 3. Next come to this part, question number 7. Write down the smallest digit in the unit place so that the number is divisible by 3. So we are going to pick B part. Let's see what number are going to fix here. Just like 8 plus 3 plus 5 plus 0 plus dash. So this is 8 to the 16, and we are having 2. If we add 2, then it will become 18 and divisible by 3. So we are going to write here the smallest number is 2. Okay, now come to our next part. Let's see what we are having next. Question number 9. Which of the following numbers are divisible by 5? So first, A part is not divisible because it is 6. So here we are having 5, it is divisible by 5. Here we are in 0, and it is divisible by 5. Next we are in question number 11. Which of the following numbers are divisible by 6? For this we are going to check the divisibility test of 2 and 3 at the same time. So here we are having this 3 at the one place, so it is not possible by 2. That is, it is not divisible by 6 as well. So first we are going to check this number. Yes, this is divisible by 2 and 3 also, so it is also divisible by 6. Okay, for this question we are going to solve this part. We have to fill a number which is exactly divisible by 6. So first we are going to do is 8 plus 4, that is 12. Now it is divisible by 6, so we are going to add as a number. That is exactly divisible by 3. So we are going to divide by 3. That is, if we write here 3, so it is not divisible by 2. So we have to add just like 6. If we add 6, this will become 18. It is divisible by 3 as well as 2 also. So then here we are going to write as 6. Clear? So come to our 13th part. Let's see F part from question number 13 to check the divisibility test of 9. So we have to simply add them just like 9 plus 2 plus 4 plus 5 plus 0. And here we are having 9 plus 2, that is 11. 11 plus 9 is 20. It is not divisible by 9, so it is not divisible by 9 too. Okay, let's pick question number 15. So here we are having what least number should be added to this number so that it is divisible by 9. So we can say that the first we are going to add the digits of this number. So here we are having 9 plus 5 plus 8. That is 22. So we are going to add 5 to make it 27. So we are having the required number. So required number is if we add 5 and this number, so it is divisible by 9. So this is our answer. If we add these digits, so it is exactly divisible by 9. So now here we are having and then that's the question number 18 that you have to complete this table by all the methods we have learned before, and our topic is finished. So thank you so much for listening us carefully. See you in next video. Till then, all the best.